Okay, so we got to go back, and they went back to talking about electricity. What is electricity? The movement of electrons, right? Okay, and when we have electricity flowing through a wire, what is developing around that wire? Demonstrated by picking stuff up? A magnet. A magnetic field is built around a wire when electricity is flowing through it. Okay? And what's the mechanical way of creating electricity? When we make electricity, what are we doing at a power plant? The mechanical form of electricity. What is happening? Not friction, that was static. And it's not chemical, a chemical reaction. We're using the magnetic field, and we're passing wires through a magnetic field. So we're going to kind of use both of those principles here to create voltage, okay? So here in this coil that I will disassemble for you guys. Okay, so take this outer cover off so you can see. All right, so this part that you are looking at right here is the primary coil of wires. Okay, this primary coil, there's about a couple of layers of them, 2 or 3 layers. All right, it's a thicker wire. You can see it's a thicker wire, and there's maybe about 100 wraps of this primary wire around and around and around and around. Okay, within the first couple layers of this paper. All right, so in this primary coil, we're going to create a magnetic field, almost like I did, and I was able to pick up, you know, some paper clips and stuff, right? Remember that? Okay, so if we pass electricity through this, we're going to create a gigantic magnet, and in doing so, a gigantic magnetic field will be built around this. Yes? Okay, so now what we want to do is take this little bit of electricity that I'm using to create a magnetic field. We want to take that little bit of electricity and we want to multiply it. How much voltage do we need for a spark? One of the questions there, I think it said something like 30,000 volts. In a car, we're using 12 volts. In your lawnmower, you might be having only a couple of volts. You're talking about a magnet passing over this coil of wire, creating a magnetic field, running a magnetic field over these wires, creating some electricity. You're maybe only making a couple of volts. For a small engine, maybe you need about 5. For a car, we're talking about 30,000 volts. So we're taking 12 volts, and we want to turn it into 30,000 volts. How are we going to do that? We're going to use that magnetic field principle again. Okay, we're going to create a magnetic field by putting some electricity into this, and then we're going to shut it off. All right? When we shut it off, that's the key point. When you shut it off. And the small engine does exactly the same thing. They use a little bit of electricity to energize the primary coil, create a magnetic field. And then they want to shut it off. When you shut it off, you have a magnetic field that is going to then pass over these wires. And this is the secondary wires, and this is the wires that do the magic. There are thousands of wraps of this really tiny, thin wire that is no bigger than the hair on your head, even smaller. And there's thousands, all in these layers. Now, when that magnetic field collapses, it absorbs into this center metal bar. That's why we're using this center metal bar, because then the magnetic field collapses and it absorbs into the center metal bar, and in doing so, every one of those magnetic lines pass over a wire. And since there's thousands of them wrapped around here, each one is able to push some electrons. So we started with 100 wraps, create a magnetic field. Now we're letting that cross over thousands of wires, and you can see how we boost our voltage. Okay? Because we've got 1,000 wires with thousands of electrons just ready to move. Okay? So when that magnetic field collapses, now out from here comes the 5,000 volts for the small engine, or 10, 20, 30,000 volts for a car engine. Okay? So that's what's happening. We are going to have, now it doesn't even matter. Sometimes this is closer to the center, and this is wrapped around the outside, or vice versa. Here, where this is wrapped around the outside, and the secondary is on the inside. Okay? The primary wraps and the secondary wraps. It could be the other way around. It doesn't matter. We're still doing the same thing. We're taking a little bit of voltage, creating a gigantic magnet, and then we're going to shut it off. And when we shut it off, all that magnetic field collapses and cuts through that secondary coil, and we get the big boost of electricity. Okay? So let me give you a demonstration on what that looks like. Let me put this back together real quickly. Alright, so here I've got set up. I've already got a power source, the battery. I've got some voltage that I'm going to use, and I'm going to send it into this coil, okay? Remember, inside of here is exactly what I showed you. 100 wraps of some heavy, thicker wire, okay? So right now, we're going to send some electricity. I got, let me charge this up here. We got our positive side here. And I'm going to send some electricity into this guy, and I'm going to create a big magnet inside of here. Okay? So right now we got a magnetic field building up, or almost, I should say. Now, the thing we need to do is shut it off. Okay? So really right now, I haven't completed this circuit, but I will right now. Okay, so right now I'm going to complete this circuit. You can see some little sparks right here, because I'm completing the circuit, kind of like when I had the two big cables, you know, and I was touching them together. So I pretty much have the same thing here. Now, when they're connected, there's a magnetic field building up here. I don't know if we can get a paper clip to stick to this right now, but there's a magnetic field building built up on this. When I separate this, the magnetic field collapses, and we should be getting a spark at this point. Okay? If you're quick enough and fast enough, you could possibly see a little spark on the bottom of this. Okay? Particularly if I try and go with this guy over here, sometimes I'm able to get it. A little spark made. But we're not going to quite get it today. But we will just skip to the next step. All right, so nobody can ever sit here and be touching wires together and create spark at the right time that the engine needs to have the spark. Which, by the way, when do we need to have the spark created?
1800, well, like at 36,000,
What?
3600 RPMs. Yeah.
Well, you know, during RPMs, what part in the four-stroke cycle do we need spark to happen? Intake, compression, power, exhaust. We want it on top dead center compression. We got intake, now we have compression. Now we want that spark to happen because the next stroke is power. We get the power stroke because the air and the fuel is burning to push that down, right? So once we get to top dead center, the compression stroke is done, which everybody calls top dead center compression. Now we want power. Now we want that spark to happen, okay? So something's got to time it to happen at the right time, and no human could ever physically do this over and over again. So they use a device. Now on the old cars, we used a device called a distributor. This is going to go like this. And this is a little bit like what the book is talking about. You guys were talking about condensers, breaker points, so on and so forth, right? Okay. Inside here are some little breaker points. This little breaker point is going to be the switch that opens and closes to either close, let current flow, build up the magnetic field, or open and let the magnetic field collapse, and then we have the big spark. Okay? And this guy, you know, the way that people designed this and engineered this, can do a much better job at turning the circuit on and off than any human can. All right, so now you can see at the spark plug, the spark. Okay? Now in a car, we use a device like this that has the breaker points built into it on this device called the distributor. Your machine has it built into the flywheel, and that coil that you guys were always taking off and putting on top of the coil, the magnet was always stuck to it. Okay, that is where this is all built into it. All right, so inside that little coil is where the switching system is, this breaker point system. Okay, so the big difference is between what we have here right now and what's on a small engine is the battery. We don't use a power source to give this thing 12 volts that we can multiply. On your small engine, they're using the magnet moving past a coil of wire to create a magnetic field, to create electricity. And then when they create electricity, they create a magnetic field in the coil. And then they're going to shut that off. Okay? So when that magnet is spinning by on that flywheel, and it comes across the top, and it goes by that coil, those magnets are energizing the magnetic field in those coils inside there. And then the breaker points open and close and shut that current off. When it opens and shuts the current off, the magnetic field collapses. You have still a secondary coil inside that device, and you get your spark. Okay? So these are the parts they're talking about. This guy even has a little condenser in here. The condenser is built in for kind of a precaution, a safety device. The breaker points, let me show you some breaker points. These are breaker points. This is what is inside this little distributor gadget. That's opening and closing. Okay. Inside here are these little breaker points. Two little contacts. Current can flow through here. This is just like kind of a switch for a light. You know, we were talking about circuits last week. So turning on and off. Now we got on, we got contact, we have electricity flowing through the primary. When it's open, oh, now this circuit's off, the primary is disabled, the magnetic field collapses, we get the spark. Okay? So I'll let you pass this around, you guys can spin this, and you can see those points right there when you're spinning it, how they open and close, how there's a little like bolt-shaped thing, an octagon-shaped thing in the middle of this. When that point comes around, that point, those breaker points pop open, and that's when you get the spark. When they're closed, the electricity is flowing through this coil, building up the primary
when that comes over here, I want you to hold it.
When
okay?
these things open and break open, you know, that's why a lot of people call them breaker points. When the circuit is broken, then the magnetic field collapses. That's when you get the big spark. Okay? So, what you guys should know, there's two parts to this ignition system. One side called the primary side, one side called the secondary side. Okay, the primary side is the low voltage that's creating the magnetic field to begin with. The secondary side is the high voltage, which is the big spark. Now, looking at what I have here, the secondary is the side that contains the high voltage spark, the 30,000 volts. What parts are we looking at here that is the secondary side, that is the high voltage side? What parts here are going to use the 30,000 volts?
Spark plug.
The spark plug, the spark plug wire, and then the coil inside, that secondary coil. So your secondary half of this ignition system is real simple to figure out. Do you have a spark plug wire that's in good shape? Sometimes you're going to see this insulation's all cracked and broken. That means the electricity is escaping out and it's going somewhere else, and it's not going to the spark plug. Your engine's not going to run. In fact, on many lawnmowers, when they don't want it to run anymore, what they're doing is taking a screwdriver and they touch here and they touch metal ground. The spark doesn't go to the spark plug to ignite. It just bypasses and it goes nowhere. And no spark, the engine dies, right? Okay. So that's what a lot of
Felipe,
machines do.
I want you to play
They
with
get
this.
ground,
Face this
is
direction
called
though.
grounding
Face this direction so I can record
this
you.
spark to
On the table, on the table.
engine metal somewhere, so it doesn't go to the spark plug, so
Play
the
around with
machine
it.
doesn't fire anymore. Okay, your spark plug
Hold it for me.
is the other thing that's important to
From
check.
right here.
If these get dirty, you're going to have
Which
problems. This gap is important to make sure the gap is right. They talk about it here in the book.
You're a wizard, Harry.
Maintaining a proper gap. There's a little tool
Pass it
you
on.
can use to measure the gap on a lawnmower engine. It should be a pretty small gap. On cars, we use a pretty big gap. Okay? On a car, it's something like a 60,000th, 50,000th of an inch. On a lawnmower engine, it's a lot smaller. It's about half of it.
I wanted you to hold it.
Okay.
I thought you were going to hold it. and I was
And
gonna
if
record-
those
I was gonna
parts
play
are
it. I was
good-
going to record it. Did you record it? Yeah. But you didn't
What
hold
else
it.
could be the problem? The coil. So pretty much on your lawnmower, if you're not getting spark and you know your spark plug works and you know you have good spark plug wire, you've replaced this. I mean, I have never replaced one in a long time on my machines. I probably do, but they still work. If I ever had a problem with my ignition system, I'd probably replace my coil, or I mean my spark plug, and then I'd say,
Arms in the way. Move that way.
how come I'm not getting spark?
chair that way.
Probably got to be my coil, right?
No, no.
Because on the lawnmower, that's really all there is. The coil and the plug. So if you're not getting spark, in fact, on today's lawnmowers, they have gotten rid of the distributor and they've gotten rid of this, and it's transistors inside there. You guys are all familiar with transistors, right? You guys have got them on your phones. Everything is all transistorized these days. So transistors, the coil, when that magnet flies by that coil, you're energizing the magnets, you're creating electricity, and then the transistors are triggered to shut off and create the spark. So if you're not getting spark on a lawnmower engine, you know you have a good spark plug, it's pretty much the coil, and you got to go buy a new coil. All right? If you've gone and bought a brand new spark plug, you can rule out spark plug problems and just say, well, my machine needs a new coil. And I think coils are like $100
That's
on a
expensive.
lawnmower. It is kind of expensive. Most people say, you know, just for a spark plug problem, I can get a machine for $300. Why should I pay $100? And that's just for the part. You're charging, you know, $80 for labor, so $200, close to $200. For another $100, I can buy a whole brand new machine. Some people are just throwing lawnmowers away just because.
Recycle it.
You know, put $200 on a used thing or buy $300 brand new, right? I'd rather have brand new too. All right? And that's why you see lawnmowers laying on the curbs all the time. If you can work on stuff, you can have yourself a pretty good running lawnmower.
Like rob all
Same
the
thing
people
with the
in
carburetor.
lawnmowers.
As I was telling you guys last unit, the carburetor is like the 90% of the problem. Today's the magnetos and electrical systems on the lawnmowers, 99.9% of the time, they never fail. On older things that used to have coils like this and older point systems, they used to have problems. They used to do a lot of maintenance. But today's things are all transistorized. They're like foolproof. They never fail. If you do have a failure because of electrical, I would like to see it. All right. It's usually carburetor. And so if you want to buy a new carburetor for $80, $100, fix other people's equipment, you can do that kind of stuff. All right. So that is part of your electrical system. Okay, your ignition system. We're talking about basic parts of the ignition. Let me go to the PowerPoint, and you guys can take a few notes here on